Hemostasis. Textbook. Guyton and Hall. Textbook of Medical Physiology. 11th edition. Pages 457 to 468. Chapter 36. Hemostasis and blood coagulation. Events in hemostasis. The term hemostasis means prevention of blood loss. Whenever a vessel is severed or ruptured, hemostasis is achieved by several mechanisms. 1. Vascular constriction. 2. Formation of a platelet plug. 3. Formation of a blood clot as a result of blood coagulation, and 4. Eventual growth of breast tissue into the blood clot to close the hole in the vessel permanently. Vascular constriction. Immediately after a blood vessel has been cut or ruptured, the trauma to the vessel wall itself causes the smooth muscle in the wall to contract. This instantaneously reduces the flow of blood from the ruptured vessel. The contraction results from 1. Local myogenic spasm, 2. Local autocoid factors from the traumatized tissues and blood platelets, and 3. Nervous rhexis. Vascular constriction. The nervous rhexis are initiated by pain nerve impulses or other sensory impulses that originate from the traumatized vessel or nearby tissues. However, even more vasoconstriction probably results from local myogenic contraction of the blood vessels initiated by direct damage to the vascular wall. And, for the smaller vessels, the platelets are responsible for much of the vasoconstriction by releasing a vasoconstrictor substance, thromboxane A2. The more severely a vessel is traumatized, the greater the degree of vascular spasm. The spasm can last for many minutes or even hours, during which time the processes of platelet plugging and blood coagulation can take place. Formation of the platelet plug. If the cut in the blood vessel is very small indeed, many very small vascular holes do develop throughout the body each day. The cut is often sealed by a platelet plug, rather than by a blood clot. To understand this, it is important that we discuss the nature of platelets themselves. The ligands, denoted by letter L, signal for platelets, P, to migrate towards the wound, site A. As more platelets gather around the opening, they produce more ligands to amplify the response. The platelets congregate around the wound in order to create a cap to stop blood flow out of the tissue. Physical and chemical characteristics of platelets. Platelets, also called thrombocytes, are minute discs 1 to 4 micrometers in diameter. They are formed in the bone marrow from megakaryocytes, which are extremely large cells of the hematopoietic series in the marrow. The megakaryocytes fragment into the minute platelets either in the bone marrow or soon after entering the blood, especially as they squeeze through capillaries. The normal concentration of platelets in the blood is between 150,000 and 300,000 per microliter. Platelets have many functional characteristics of whole cells, even though they do not have nuclei and cannot reproduce. In their cytoplasm are such active factors as 1. Actin and myosin molecules, which are contractile proteins similar to those found in muscle cells, and still another contractile protein, thrombostatin, that can cause the platelets to contract. 2. Residuals of both the endoplasmic reticulum and the Golgi apparatus that synthesize various enzymes and especially store large quantities of calcium ions. 3. Mitochondria and enzyme systems that are capable of forming adenosine triphosphate, ADP, and adenosine diphosphate, ADP. 4. Enzyme systems that synthesize prostaglandins, which are local hormones that cause many vascular and other local tissue reactions. 5. An important protein called Brin stabilizing factor, which we discuss later in relation to blood coagulation, and 6. A growth factor that causes vascular endothelial cells, vascular smooth muscle cells, and broblasts to multiply and grow, thus causing cellular growth that eventually helps repair damaged vascular walls. The cell membrane of the platelets is also important. On its surface is a coat of glycoproteins that repulses adherence to normal endothelium and yet causes adherence to injured areas of the vessel wall, especially to injured endothelial cells and even more so to any exposed collagen from deep within the vessel wall. In addition, The platelet membrane contains large amounts of phospholipids that activate multiple stages in the blood clotting process, as we discuss later. Thus, the platelet is an active structure. It has a half-life in the blood of 8 to 12 days, so that over several weeks its functional processes run out. Then it is eliminated from the circulation mainly by the tissue macrophage system. More than one-half of the platelets are removed by macrophages in the spleen, where the blood passes through a lattice-work of tight trabeculae. Mechanism of the platelet plug. Platelet repair of vascular openings is based on several important functions of the platelet itself. When platelets come in contact with a damaged vascular surface, especially with collagen burrs in the vascular wall, the platelets themselves immediately change their own characteristics drastically. Mechanism of the platelet plug. They begin to swell, they assume irregular forms with numerous irradiating pseudopods protruding from their surfaces. Their contractile proteins contract forcefully and cause the release of granules that contain multiple active factors. They become sticky so that they adhere to collagen in the tissues and to a protein called von Willebrand factor that leaks into the traumatized tissue from the plasma. They secrete large quantities of ADP, and their enzymes form thromboxane A2. The ADP and thromboxane in turn act on nearby platelets to activate them as well, and the stickiness of these additional platelets causes them to adhere to the original activated platelets. Therefore, at the site of any opening in a blood vessel wall, the damaged vascular wall activates successively increasing numbers of platelets that themselves attract more and more additional platelets, thus forming a platelet plug. This is at RST a loose plug, but it is usually successful in blocking blood loss if the vascular opening is small. Then, during the subsequent process of blood coagulation, Brin threads form. These attach tightly to the platelets, thus constructing an unyielding plug. Importance of the platelet mechanism for closing vascular holes. The platelet plugging mechanism is extremely important for closing minute ruptures in very small blood vessels that occur many thousands of times daily. Indeed, multiple small holes through the endothelial cells themselves are often closed by platelets actually fusing with the endothelial cells to form additional endothelial cell membrane. A person who has few blood platelets develops each day literally thousands of small hemorrhagic areas under the skin and throughout the internal tissues, but this does not occur in the normal person. Blood coagulation in the ruptured vessel. The third mechanism for hemostasis is formation of the blood clot. The clot begins to develop in 15 to 20 seconds if the trauma to the vascular wall has been severe, and in 1 to 2 minutes if the trauma has been minor. Activator substances from the traumatized vascular wall, from platelets, and from blood proteins adhering to the traumatized vascular wall initiate the clotting process. The physical events of this process are shown in figure. Within 3 to 6 minutes after rupture of a vessel, if the vessel opening is not too large, the entire opening or broken end of the vessel is LLED with clot. After 20 minutes to an hour, the clot retracts. This closes the vessel still further. Platelets also play an important role in this clot retraction, as is discussed later. Do you have any question?